Good morning, students. Today I am going to start a new chapter, that is surface chemistry. So let's we see a definition of surface chemistry. What is surface chemistry at first? So write down the definitions. A branch of chemistry which deals with nature of surface and changes occurring on the surface. This is known as surface chemistry, students. It is also one of the important chapter because number of times questions were asked in this chapter. So it is very easy to learn descriptive type. So create your interest in this chapter and learn all the topic given in this chapter. So this is simple definition of surface chemistry, which deals with nature of surfaces and changes occurring on the surface. This is called the surface chemistry. In this surface chemistry, at first we discuss about the topic adsorption. So write down the what is adsorption. So in class 9th you have read about the adsorption or absorption. So what is the difference between absorption and adsorption? Absorption, as we know, is the bulk phenomenon and adsorption is the surface phenomenon. So we will discuss here about the adsorption first. So what is adsorption? The phenomenon in which the concentration of the substance in which the substance is higher at the surface, as compared to the bulk of other substance. So students, let's see explanation about the diagram. Suppose we have a chalk we use in the classroom, chalk and a sponge. This is chalk and we take a piece of sponge and 1 pot of ink. Dip the chalk into the ink and see what happens. So you will see when you dip the chalk in the ink pot or ink deposit on the chalk, you will see the chalk only show the presence of ink on this surface. If you suppose if we dip in this side or inside, suppose we break the chalk, we will find only the ink present on the surface here and here, and their core part is as it is, which is suppose chalk is a white in color, so their core part is also white in color, only the ink present on this surface here and here. But when we dip the sponge in the ink and see what happens, after squeezing we see ink present in the bulk of the sponge and ink present only on the surface of the chalk. So this phenomenon, sponge contain all the ink, means ink present in the bulk of this particular sponge is called the absorption. Because absorption is a bulk phenomenon. It is the bulk phenomena, and it is called the adsorption. Adsorption because it is the surface phenomena. Surface phenomena. So we only read about in this chapter, or we give our main focus on this particular topic in the surface chemistry, adsorption, the phenomenon in which the concentration of the substance is higher at the surface. The concentration of substance is higher at the surface as compared to the bulk of other substance. So let's discuss the two particular terms also regarding this. The first term is adsorbate. So let's discuss what is adsorbate. The substance which stick at the surface of adsorbent first we discuss the adsorbent. And second thing is adsorbate. Adsorbent, the substance at which other substance stick on its surface is called adsorbent. For example, chalk, wood charcoal, animal charcoal, silica gel. Only the moisture absorbed at the surface of silica gel, etc. So it prevents the moisture. So we use silica gel in very number of times in different equipments. So let's see the another terms which is called the adsorbate. The substance which stick at the surface of adsorbent is called adsorbate. For example, ink, moisture, color material, of raw sugar, etc. So few are the examples of this particular. We can say that this is adsorbent or this is the adsorbate. For example, suppose we have chalk and ink present at the surface of this particular chalk. So ink is called adsorbate, and chalk is called adsorbent. adsorbent. So students, don't confuse. Yeah, always remember what is adsorbate and what is adsorbent. So let's we discuss the next term, that is called the sorption. Sorption. When adsorption and absorption both occur simultaneously, the process is called sorption. Process is called sorption. For example, suppose we have a substance which is silica gel. We know that it prevents from moisture because it absorbs at the surface of their surface. So this is the example of adsorption, because it absorbs the moisture at their surface. Suppose we have calcium chloride. We know that this absorb moisture. So this is the process of absorption. And suppose we have a fabric, or if we dye this fabric, so when dye this fabric, it is called the adsorb, because it's present at the surface, as well as fabric present in the bulk of the dye present in the bulk of this particular fabric. So this is called the absorb. So both the phenomenon takes place: adsorption at the surface, dye present also, and dye also present in the bulk of the fabric. So both the process takes place in this fabric. So this is the example of sorption. So this is the simple difference between adsorption, absorption and sorption. So remember it. Don't number of times this type of definitions asked in the examination. Define absorption, define adsorbent, define adsorbate. Maybe this type of questions asked. So let's differentiate the absorption and adsorption. So differentiate between adsorption and absorption. What is the difference between this? So most clear difference between it is the surface phenomena and it is the bulk phenomena. In adsorption, concentration is higher at the surface as compared to bulk. But in absorption, concentration is uniform throughout the bulk. Let's discuss the mechanism of adsorption and thermodynamics of adsorption. So let's we discuss the mechanism of adsorption. Why adsorption takes place. So our topic is mechanism of adsorption. The first condition, adsorption occurs due to the unbalanced forces acting on the surface molecules. Surface molecules. The molecules which is present in the bulk of the solid experience attraction forces from the other molecules, and the net force acting on it is 0. But the molecules present at the surface, at the surface experience inward attraction by the bulk molecule. This attraction is unbalanced. This attraction is unbalanced. Next reason is due to this unbalanced residual forces, the surface molecule attract other molecules and adsorption occurs. Suppose we have a surface and there is the molecules present, and here is also a number of molecules present in the bulk. Suppose a molecule is present here, so all the molecules in which force of attractions takes place, so their net force becomes 0, and these molecules also attract towards itself. So the inward force acting on it. Suppose here is the molecules, surface molecules. So here is the inward force acting on it. Acting on it. So that the residual force, if any molecules present or come on the surface, they attract towards it. So they attract towards it to balance this unbalanced force, because this surface molecules attract towards inwards force. So in the bulk molecules, the net force is 0 because they are balanced by the other molecules present in the bulk. But at the surface molecules, there is a only inward force act. The residual force is present. So this residual force is the reason for the adsorption of molecules, because when the molecules come on this particular surface, they attract towards itself and adsorption occurs. So this is the reason for the adsorption takes place at the surface molecules. Why the surface molecules only attract the incoming molecules? Because as we written here, the molecules which is present in the bulk of the solid experience attraction force from the other molecules, and net force acting on it is 0. But the surface molecule, which is the surface molecules, this surface molecule which is present experience inward attraction, because here is also molecules, bulk molecules present. So this surface molecules experience inward attraction by the bulk molecules. This attraction is unbalanced. Due to this unbalanced residual force, the surface molecule attract other molecules. Suppose other molecules come, so this attract by this surface molecules, and adsorption occurs. This is the phenomenon for the adsorption, which takes place at the surface of the molecules, surface of the substance, surface of the. Let's we discuss thermodynamic of adsorption. Thermodynamics of adsorption. For spontaneous process, we all know that for a spontaneous process, we know that Gibbs energy, change in Gibbs energy less than 0, or we can say that change in Gibbs energy should be negative. Should be negative. And the equation is change in Gibbs energy is equal to del H minus T del S. This is enthalpy, this is entropy, and this is the energy. Since adsorption is entropy, suppose we have surface molecules in adsorption process, we know that this is the surface phenomenon. When the gas not attract on this surface, they are free to move in anywhere. When they attract towards this, their randomness, their entropy decreases. So we can say that adsorption process, so since in adsorption entropy decreases, and therefore what happens? Change entropy becomes negative, because entropy, as the gases molecules attract at the surface, their randomness decreases, their entropy decreases. So entropy becomes negative. And when delta G, for spontaneous process, delta G must be negative, and delta H minus T del S. Del S is also negative, here will be positive. But for the spontaneous process, this particular enthalpy must be negative, more negative. For adsorption, for adsorption, delta H must be negative, because we know that in enthalpy process, adsorption process is a exothermic in nature, because during adsorption energy releases. So we all know that adsorption process is the exothermic process. So as we know, adsorption is an exothermic process. Exothermic process. Why? Because during adsorption energy release. So this is the exothermic process. So students, डेल्टा जी स्पॉन्टेनियस प्रोसेस के लिए नेगेटिव होना चाहिए और डेल्टा एस भी नेगेटिव है, तो यहाँ पर क्या साइन आ जाएगा, माइनस माइनस प्लस साइन हो जाएगा, जबकि क्या आना चाहिए, डेल्टा एच क्या आना चाहिए, नेगेटिव आना चाहिए। तो और इनफैक्ट हाई नेगेटिव होना चाहिए, तभी डेल्टा जी हमारा नेगेटिव होगा। सो फॉर दिस प्रोसेस we know the conditions. Delta H must be negative. For the spontaneous, this negative, this must be negative, and for the negative delta G. So in this way you can simply define the thermodynamic conditions for adsorption. Delta J must be negative, so delta G must be negative, and delta S is also negative, and delta H must be negative. This conditions, because as we know this is the exothermic process, so this will also conditions given for the adsorption in thermodynamic condition. So let's we discuss the types of adsorption. So this is the condition delta H or must be greater than T del S. So in this way you can explain the thermodynamic reason. Next we discuss the types of adsorption. Our next topic is the types of adsorption. Depending on the type of attraction force, depending on the type of attraction forces between adsorbate and adsorbent. The first is called physical adsorption or physisorption. Next one is chemical adsorption or chemisorption. What is the difference between physical or physisorption or chemisorption? So at first we discuss about the physisorption. When adsorbate molecules are bonded to the adsorbent surface by weak van der Waal force. Weak van der Waal forces is called physiosorption. Physiosorption or physical adsorption. For example, as we study, suppose this is the surface and this is the molecules, and suppose the molecules come here and the surface molecules attract. There is a weak force of attractions between them, which is called the van der Waal forces, because we know that van der Waal forces act between any two molecules. This is adsorbent, and this is adsorbate. So in this way you can explain the physiosorption. Remember one thing more, in this process is multi-layer in nature, because when this layer attracted by this particular layer, so this particular layer also attract another layer, because this and this again a force of attractions, weak force of attractions created. It is also van der Waal forces. Another layer is also formed by these two molecules. So in this way you can explain, or physiosorption is the multi-layer in nature, because on the surface of adsorbent more number of layers form. So this is the physiosorption is multi-layer in nature.